I'm Anil Kumar, and in this series, we are sharing questions from previous test paper on vectors. Now, this is a question from IB test paper. We'll understand skew lines with the help of this example. The question here is, show that the following equations represent skew lines. L1, r equals to minus 6, 12, 8 plus t times 2, 1 minus 5, and L2 is r equals to 8 minus 9 minus 7 plus s times minus 2, 1 minus 5. Now let's understand what are skew lines. So skew lines are the lines which do not intersect. So what are skew lines? So lines which are not parallel and they do not intersect, right? These are two characteristics. What is the reason for their being not parallel, still not intersecting? The reason being is that they are in parallel planes. Since they are in parallel planes, planes will not intersect, so the lines will not intersect. That's the basic concept. Okay. Now with that, let's see whether the given lines are parallel or not. So you can see that M1 is equals to 2, 1 minus 5, and M2 is minus 2, 1, 5, correct? Now you can see they are different, correct? So we know M1 is not equal to M2. That means that the lines are not parallel. So means lines are not parallel. Now we need to figure out whether they intersect or they don't intersect. That's the second part, right? How will you do that? Now we can write these equations in parametric form. Let's do that. For line 1, it is minus 6 plus 2t. That's the value of x, right? For y, we can write 12 plus t. For z, we can write 8 minus 5t. For the other line, we can write x as equal to 8 minus 2s, y equals to minus 9 plus s, and z equals to minus 7 minus 5s. So these are the equations for us. Now we have to solve two equations to get the parameters, right? So we'll prefer to solve these two, right? That'll be easy actually. So let's solve these two equations. Once we solve these two equations, we can substitute the value for z and see if z is a valid point for us. Okay. So to solve these equations, let me rewrite them. So that means solving really means that if they intersect, x coordinates should match, correct? That is to say, we can write this as minus 6 plus 2t should be equals to 8 minus 2s, right? Let's simplify this as we move along. We'll bring 2s here plus 2t, keep numbers on the right side, which is 8 plus 6 equals to 14. I can divide by 2, simplify this as s plus t equals to 7, right? So this equation I've got from comparing the x coordinates, right? Now we will compare the y coordinates to get the other equation. 12 plus t equals to minus 9 plus s, bringing s to this side. We can say minus s plus t equals to minus 9 minus 12, which is minus 21, right? So we get minus 21. So we get two different equations which we can further solve for t and s, right? Okay, so let's rewrite these equations and then we'll solve them. correct. Let's rewrite there. So what we have here is equation which we are taking into consideration is this one, which is s plus t equals to 7, and the other one is this one, which is minus s plus t equals to minus 21, right? Now if I add these equations, right, so if I add them, then what happens? S and minus x cancel. We get t plus t as 2t. So we get 2t equals to, adding will give us minus 14. Or t as equals to minus 14 divided by 2. That is minus 7. Correct? So that is how you can get the value of t. Now from here you can find what s is. So we know s is equals to 7 minus t, which is 7 minus 7, which is 14. So we get the value for s and t, right? Since we get both values of s and t, we can find all these points, correct? So for these values of s and t, z point should match. That is very important, right? So the others should also match if there is a point of intersection, correct? If not, then they will not match. That's the whole idea, correct? So let's substitute in z. So if I substitute in z, so what we are doing here is we are substituting s as okay, let's write down here. So now we'll substitute s equals to 14 and t equals to minus 7 in our equations to find the points of intersection. So especially we are interested in z, right? So let's first do it z. 8 plus, minus 5t. Minus 5 times t is minus 7, and that gives us a value of 8 plus 56, right? So that is 64. This is from the first equation. This is from this equation, right? Now let's use the other one, which is z equals to minus 7 minus 5s, which is minus 7 minus 5 times s is 14, right? You can also use the calculator to figure this out. But it's very clear that's a negative value. It's not close to 64 at all, right? So it is, we could do just 7 plus 5 times 14. I'm sorry, s value is positive, t value is negative, right? So t value negative, that's fine. So we use the same way, right? Okay, so we'll just add this up and we get 77 with a negative sign. So clearly z values do not match. Now since z values do not match, these lines do not intersect, correct? That's the whole idea. You'll find that if you substitute the values of t and s in x and y equations, you'll get matching results. So you can try that out. Let's figure it out. For x is minus 6 times plus 2 times t. T is minus 7, right? So that gives us minus 6 minus 14, and that is minus 20. So if I substitute in the other equation, then we get x equals to 8 minus 2 times s is 14, right? And that is 8 minus 28, and that is minus 20. So we find that the x values of both match. Similarly, you can find y values also. So I'll leave that for you. So find y values also. If I substitute minus 7 here, so we get y is 12 minus 7 for t, right? That gives us the value of 5. And if you write 14 in this equation, then you get minus 9 plus 14, which is also equals to 5. So you can see x and y values match, but not the z value. Therefore, these lines do not intersect. Since these lines are not parallel and they do not intersect, they are skew lines, right? So not parallel, and not intersecting means skew lines, right? So that is how you can prove. I hope that helps. I'm Anil Kumar. You can always share and subscribe my videos. Feel free to write comments. Thank you and all the best.